we'll discuss about the Thevenin theorem. Thevenin is basically a scientist name, okay, and on the basis of his name he gave this theorem. So for to solve the theorem we'll need to follow the certain steps, okay. Step number 1, that we need to find out the value of load resistance, okay. Well, for this you should know what is the value for load resistance. Load resistance is denoted by RL, and in whichever branch they'll ask you to find out the value of current, that is the load resistance. Like suppose this is the simple circuit I'm taking for explaining. This is a 4 ohm, 6 ohm, 8 ohm, 10 ohm and 12 volt, and they have said that the find current in 10 ohm resistor, okay, in the question by using Thevenin theorem. So they are asking the current in which branch? 10 ohm, right? They are asking the current in which branch? 10 ohm. So this 10 ohm is the load resistance. So this one is the load resistance, so we'll consider RL as a 10 ohm. So they'll give you to find out the current only in the single branch. They don't give the multiple branches to find out the current. So that particular load resistance is the RL. Load resistance is like the load you understood, I think, like you are using fan at your home, AC at your home, that is the load. Okay, so fan resistance is the load resistance. Step number 1 clear. Next is step number 2. Yeah, step number 1 was we'll find out the value for the load resistance, and step number 2 is we have to open circuit the load resistance. Okay, I think you know about the what is open circuit means. We have to remove, yeah, we have to remove the RL, so then the circuit will become open circuit. Now I'm drawing the complete circuit for based on that. Here it was a voltage source, then a resistance, then we are having at point A and B terminal there was a load resistance. Next thing you need to remember that always mark A and B, okay. In whichever branch you need to find out the current, always mark A and B, because according to A and B I'm telling you. Okay, so open circuit RL, or we can say open circuit the resistance across A and B terminal. We remove it. Clear? So now we'll mark rest of the resistance. 4, 6, 8 was the rest of the resistance. 4, 6, 8, and this is of 12 volt. Step number 2 is also clear. Now step number 3, whichever branch like from A and B terminal we remove the load resistance. Now in this particular branch we have to calculate voltage. So calculate voltage across, you need to calculate voltage always across A and B terminal, okay. That is known as Thevenin voltage. On the basis of his name, because his name is Thevenin na, so on the basis of his name he gave this Thevenin voltage, and Thevenin voltage is denoted by VTH, and we can conclude that VTH is equal to VAB. So at this particular A and B, that's why I told you to mark A and B always. We need to VTH is equal to VAB. VTH, this is the Thevenin voltage, or we can say that this is the voltage across A and B, right? So now just imagine that you are standing at the A position and you need to move to B position, right? So, but there are two paths. How can you move to B position? Like you are standing at A position, you can move to C, you can move to E, E to F, F to D, and D to B, right? This is one of the path, but this is the longest path. You can follow the shortest path also, A to C, C to D, D to B, right? So can we write down that VAB is equal to VAC plus VCD plus VDB? Can we write down this thing? You can, if you want that, you can follow the long path also. If you want, you can follow the short path. It's up to you only. You are standing at A position, you need to move to B. As you can see that there is no direct connection between A to B, so you need to follow this path. Okay, clear? Now according to Ohm's law, formula of voltage is V is equal to I multiplied by R, right? So for VAC we can write down IAC multiplied by RAC. Can we write down? Similarly for VCD, what we can write? Tell me. VCD is equal to ICD. VCD is ICD multiplied by RCD. Similarly, tell me for VDB, it would be multiplied by RDB. Okay, so if we'll get all the values, then we'll get the value of VAB. Yes or no? If we'll put all the values, then we'll get the value for the VAB. Okay, then we'll see what is RAC. RAC is the resistance across 8. We don't know the value of IAC, right? ICD again we don't know, but RCD we know. That is how much? 6 ohm. IDB again no, we don't know, but RDB is 0, so everything is 0 only. As you can see that there is no resistance across D and B, right? Now see, this is a plain wire, open circuit wire. Can you flow from C to A and then further? In open circuit, current won't flow, so IAC value would be equal to 0 only. So can we put IAC is equal to 0? Because we don't know the value of current, because we here current can't be flow because it is an open circuit, right? So now if we'll get the value of ICD, then we'll get the value of VAB as well, right? So now for VAB, so for now ICD, we need to calculate ICD. Now our focus is on ICD, right? So for ICD, can we apply KVL? Simple. This is the current flowing in ICD now. So can we apply KVL? If we need to mark sign, here it is positive because current is flowing like this. Here it is negative. Now current is flowing from C to D. Here it is positive. Here it is negative. And battery sign will remain same. Here it is positive and here it is negative. Clear? If I'll apply KVL, then what would be the value? Minus 4 ICD minus 6 ICD plus 12 is equal to 0, right? Then if we'll solve minus 10 ICD plus 12 is equal to 0, then ICD value would be equal to minus 12 by 10, that is 1.2. Got it? How much we got for ICD value? That is 1.2. Correct? Now can we put the value of ICD here to get the value of VAB? ICD value how much we get? 1.2 multiplied by 6 is how much? Tell me. 6 multiplied by 1.2 is how much? 7.2. Okay. So what will we get the value for VAB? We'll get VAB as 7.2. Sorry, it's 2. Right? So we'll get the third step, and what was the third step? That will get the VAB is equal to 7.2. I'm telling you again this step. We need to calculate the Thevenin voltage. Thevenin voltage must be across A and B terminal always. Okay, just imagine that you are standing at A position and you need to move to B position. Okay, so you can choose the shortest path, like you can move A to C, C to D and D to B. That's why I write voltage, because we want voltage across A and B na, so it would be VAC plus VCD plus VDB. As you can see that there is no current flow, then VDB would be equal to 0 only. As you can see that there is no current flowing across through AC, so VAC would also be equal to 0. What is the left one? That is ICD multiplied by RCD. RCD is given, that is they have mentioned 6 ohm. ICD we can calculate it by using KVL method. We'll get the value of ICD and then we'll get the value for VAB. Clear? Now next step number 4, we need to calculate Thevenin resistance. Okay, we need to calculate Thevenin resistance. Thevenin resistance is denoted by the term RTH. To calculate Thevenin resistance, we have to follow certain steps, that is, voltage source must be short circuited as you have done in the Thevenin, and current source must be open circuit. Okay, remember I told you now that voltage, yeah, this is also the same for the superposition. Remember I told you for voltage source is your relative, so whenever your relative come to your house, you close the door, and current source is your friend. Whenever your friend come to your house, you open the door. Okay, so now I'm drawing the circuit. This is the circuit. Here is only voltage source is there. There is no current source. Only one source is there. This is what, because I have taken simple question to explain you. Okay. So voltage source was there. I shut the door for my relative. And next is resistance would be same. Okay. Now here is A terminal and here is B terminal. Okay. What was the value? 4, 6, 8. So I am writing down the value 4, 6, 8. Now from these two terminal we need to calculate RTH, means we need to calculate RAB. Okay. Now see, again I am telling you a trick. A is your home. Okay. And you are standing, you are at home, and you need to move to B. Okay, like just imagine that you are standing at A position and you need to move to B position. Okay, so if you want to meet your friends, that 8 ohm is your friend, 4 ohm is your friend, and 6 ohm is your friend. Okay, so which of the two friends are coming in the same path, means they are connected in series, and which of the friend are coming in different path, like you have to think that I can go to 4 ohm house or 6 ohm house, then that resistances are connected in parallel. Different path means parallel and same path means series. Okay, so now you are moving from A, then you move to 8 ohm house friend. Okay, then now tell me, this 4 ohm and 6 ohm are connected in the same path or in the different path? Different path now. So this 4 ohm and 6 ohm are connected in series or in parallel? Th- this is connected in parallel, right? So these are connected in parallel. So we can conclude, and it will form a single resistance, that is 4 parallel 6, correct? Now 8 ohm as it is, this one is A, this one is B. Now you are again at A and you need to move to B. This 8 and this friend are in the same path or at the different path? So they are in the same path, it will be connected in series. So RAB resultant would be 8 plus 4 parallel 6. Okay, it is a simple circuit, that's why it it is solved so easily, otherwise it is not so. So 8 plus 4 into 6 divided by 4 plus 6, so it would be 8 plus how much it is, 10 divided by then you can solve it further. Okay, whatever it will be the value, you will get the value for RTH. Next, last and final step, step number 5, we need to calculate current. Okay, they are not asking the value of VTH, right? They are not asking the value of RTH. What they are asking in the question, the value of current. Okay, so how will you calculate the value of current? You have calculated VTH, so connect VTH, and you have calculated RTH, connect RTH in series with VTH. These two are always connected in series. Voltage with the resistance in series, and this was the A and B terminal. Okay, so you have removed earlier from A and B terminal the load resistance, right? So now you connected back the load resistance to A and B terminal, and here how much current is flowing? I. Okay, so now we need to calculate I. I is how much, that is according to Ohm's law, V by R. Here V is how much, VTH. Here R is how much, RTH, and RL are in series, so we can say that RTH plus RL I. So we know the value of VTH, we know the value of RTH, we know the value of RL. From that we will get the value of I also. Clear? So this formula you need to remember, or you can conclude it directly from the diagram. This is the main formula for the Thevenin theorem. Okay. Now I am telling you by a simple story so that you will never forget this question in your life. Like this is RL. RL is how much? 10 ohm. Okay. Just imagine this is you. Okay. You are the RL and your value is 10 ohm. Okay. So what they did, what your parents did with you, they said that get out from our house, you don't do any work. Okay. So they removed the 10 ohm from their home. This is their parents home, this is you. Yeah, and they removed you from your home. Okay. So now but after removing you, like they said, get out from our house, they'll feel bad, and then they calculate potential. Obviously you will have some potential now in you, so they'll calculate potential. Okay. They'll calculate your potential, that how good are you, like you can do some of the works at least, that you are good in that work, you are good in that work, you are good in that work. So they calculated all the potential across you. Okay. Then they calculated resistance also. Resistance is like you can consider as a weakness, because there are obviously, if they remove you from your house, then there must be some weakness now. So then they calculate their weakness, means in the form of resistance they calculate your weakness also, right? Okay. So after combining, they put out all the things, they put it your potential, means how strong you are and where you are strong. They put it your weakness also, that here my son is weak, and they put it in series. Okay. And bring back to your home, that they said sorry, no, you are good enough to do work. Okay. Understood? No, you can remember, like you can remember these steps in this. So first you are removed, then they are calculated potential across A and B, then they calculated your weakness, means the resistance across A and B. Then they bring back to you at the same position A and B and calculated the overall current. Okay.